so we're going to talk about the conjugate today. We are going to finish out chapter 1. We'll probably start on chapter 2, just because we can, for the time. When we get to the point where, especially on these units where we have more than one chapter, when we get to the end of unit 1 and we start, or end of chapter 1 and start chapter 2, there is a big jump. Remember how we started this chapter? It was very easy, simple, and then it got harder and harder and harder. Well, chapter 2 is going to do starting easy and getting harder again. So we're going to stop with the hardest one and start with the easiest one. So it's like big jump in difficulty. So it's okay. We're going to get through our hardest stuff. We'll end with some easy stuff, and we'll have a little bit of time for questions. So we should be good. So we're going to talk through our conjugate again because it's kind of a weird concept. We're going to be trying to force these to complete the square so we can get radicals out of our denominator. I'm going to turn that off because I'm not doing a review anymore. So we had this example one yesterday where we looked at 1 over square root of x plus square root of y. And when we are creating the conjugate, what that means is we take the exact same pieces, and that pen is way too chunky, where we have our square root of x and our square root of y, but instead of using the exact same sign, we use the opposite sign. What that does is that's forcing these two pieces to be a complete the square so that we wind up with no radicals in our denominator. Because when we multiply out that denominator, we'll see what happens here in a second, but I need to fix this because in my numerator here, I need to put the exact same thing. Square root of x minus square root of y. Because we are dealing with expressions here, so we always need to multiply by 1. It can be a funny looking 1, but it's got to be a 1. So when we multiply out this denominator, which if you do so and combine your like terms at the same time, totally fine. I'm going to actually write it out because we don't have to like rush for time this time. So if we multiply out our square root of x times square root of x, we get square root of x squared. If I have my square root of x that we multiply by the minus y, we're going to have minus square root of xy. We can multiply our radicands together under the radical. Totally fine. When we take our square root of y times square root of x, we have our positive square root of xy, or yx. Genuinely does not matter. And then we're left with our minus square root of y times square root of y, so minus square root of y squared. Our numerator is exactly what we had on the top, our 1 times this hot mess. It's kind of gross, but he's a guy. He's there. It's a thing. But if we look at our denominator here, square root of x squared, that's just x. I'm just going to put down here so we're going to have our x. Our minus square root of xy and our plus square root of xy, those guys cancel each other out. And we're left with our minus square root of y squared, which is just y. So we're winding up with no radicals in our denominator. We put them in the numerator instead. Square root of x minus square root of y. And we're going to practice this with a couple more examples that are different. But since we're not rushing for time, I wanted to talk through that one again a little bit slower because I know we were kind of right at the end of the period yesterday. The whole point of this, and the reason we need to do this, is because we do not keep radicals in the denominator. We're not allowed to have radicals in the denominator. It is bad format. So let's practice this a couple of times. We are going to rationalize our denominator using the conjugate on these two. And they're a little small, but they're not too bad. So we've got 1 over the square root of x plus 5 as our first one. And we want to rationalize this. The whole point of this is to get the radicals out of the denominator. That's the problem. So when we are creating our conjugate, we're going to make a fraction. And we take these exact same pieces. So we're going to have our square root of x and the 5. Exact same pieces. Just instead of using the plus, we're going to use a minus. So this is our conjugate. Since I cannot just randomly multiply by that on the denominator, we use it as our numerator as well. Square root of x minus 5. When we multiply these pieces together, we're going to have our square root of x times square root of x. It's going to give us our x. We're going to have our 5 square root of x and our minus 5 square root of x. Those guys are going to cancel out. And we're left with our 5 times minus 5, giving us minus 25. Our numerator is going to be our 1 times what we had as our conjugate here. So our square root of x minus 5. And I know it doesn't look better, but technically, mathematically, it is. I know it doesn't look better. But what this does is this fixes those square roots in the denominator and gets rid of them. That's what we care about, is we got to get the square roots out of the denominator. And then we're going to try the same thing on the right-hand one. These don't get worse. A lot of times we'll give you a problem and then we'll be like, oh, a little harder, and then a little harder, and a little harder. These don't get worse. They are what they are, or at least this semester they don't get worse. What's that?
Since it's plus 3 and negative 3, would that cancel out or not?
They don't cancel because they would have to be exactly the same to cancel out. Always a good idea to check though. Coffee's going. At every drop. All right. So now if we're looking at this one on the right, we've got our square root of a plus 3 over square root of a minus 3. And we're still going to try and find that conjugate. Whoa, wrong pen. There we go. I'm going to put it on the left side just because this is very close to the wall. But it does not matter which side you use. We're multiplying. It doesn't matter what order we pick. I just ran out of space. So we use the exact same terms, our square root of a and our 3. We just use the opposite sign. So we're using a plus. And I know we're super duper tempted to come here and go, well, I could cancel stuff out. It doesn't help though because we still need to get the square root out of the denominator. So canceling things out doesn't get rid of that square root. So we're going to multiply by our funky looking 1 and we're going to see what happens. Square root of a plus 3. So what are we going to wind up with in our denominator? A minus what? 9. So just be careful with that because we need to make sure we wind up with our term squared. And then in our numerator, we have our square root of a plus 3 times square root of a plus 3, which we can do shortcut form as square root of a plus 3 squared. We don't need to fully multiply it out. You can if you want to. You'll get a plus 6a squared, or plus 6 square root of a plus 9. You don't need to. Leaving it like this is totally fine. The thing we're looking at here is our denominator, making sure we have no radicals down here. As long as we have no radicals in our denominator, we have rationalized it, and it is a perfectly acceptable answer. If you want to multiply it out in the numerator, totally fine. It will not simplify. I've got 2 more problems for us to look at from section 1.4. There's a weird one on the homework that has instructions to say express this as a sum of terms of the form ax to the r. What we're trying to do is get this to not have the x in the denominator. So easy way to do this is to kind of treat this like monomial division, where we're going to take our 4x squared minus x plus 5 that we're dividing by x to the 2/3, and we're going to split it apart into separate fractions. Our exponents are going to become less pretty to our eyes, but it's going to make it to be not fractiony as an expression. So with these kinds of problems, the way that I recommend we do them, and they're not going to be something we see super frequently, but it's something we see occasionally, is I want to take my 4x squared and my minus x and my plus 5, and I'm going to set those all up as their own numerators that we are dividing by x to the 2/3. X to the 2/3. So I'm uncommoning this denominator. As long as there's not adding or subtracting in the denominator, we can split it apart like that to simplify. 100%. If we have adding or subtracting in the denominator, that's when we need to factor before we could start doing any simplifying stuff. So once we have it like this, we're going to try and combine our x's together. We may get fractions, we may get negatives. It's okay, we can do that. When we have an expression like this, 4x squared over x to the 2/3, what can I do with these exponents to make them combine together? Subtract them. So this is going to give me 4x to the, what is 2 minus 2/3? As an improper fraction. 4/3. And if it helps, write it out like that. Put our subtraction in there. What exponent does this x have? 1. So when we're looking at our subtraction here, it's going to be 1 minus the 2/3. So we're going to have x to the, what's our simplified exponent on this one? 1/3. On this one, I don't have an x to subtract from, though. So what are we going to have as our exponent on the x here? How can I get it up onto the main line? Negative 2/3.
I'm confused.
Which part?
How did
The last one?
no, the first one.
First one.
Yeah, how did it go from 2
Mm-hmm.
minus 2/3 to 4?
Think of it, if we need to common denominator, 2 expressed as thirds would be 6/3. Yes? 6/3 minus 2/3. Okay?
Kind of frame the word.
Understood. When in doubt, think of it as needing to get them to common denominator. Again, it's not going to be something we see tons and tons and tons. Occasionally, but not super duper tons. What does a negative exponent do? It flips it. So even if it's in the bottom, if I have 1 over x to the minus 2, I would put it up on the top and have this be x squared. This is the same thing as having an x squared. So if I have something in the denominator and I want it to go up top, I can make it negative. Or you can think of this as x to the 0, because x to the 0 is 1. And so you could do this as, switching my colors, rematch. Ooh, wrong spot. Our 5x to the 0 minus 2/3, which simplifies to negative 2/3. If that helps, do it that way, totally fine. But it's using this negative exponent property that if I have something up here that's negative, it goes in my denominator. If I have something in my denominator that's negative, it goes up. it always flips it across that fractional.
What happened to the x's on the denominators and the other two fractions?
They got combined together in here. We subtracted our exponents. That's where this, because this was, I'm just going to switch this back to be the 2. This was our 2 minus the 2/3. So it's our numerator power. It's the square minus the 1 from the denominator. The 1 minus the 1 from the denominator. The 0 minus 1 from the denominator. So it's simplifying this in a very weird way. Again, it's not going to be something we have to do super duper tons of. Occasional, but not super common. Yeah, really not super common. I think there might just be one of those in the homework. Artemis B. Okay. Oh, I heard a Miss B, so I was doing my Scooby ears trying to figure out where it was. Okay. I want to look at one more from this section because they look super ugly. I promise they're not awful. One of these. I know. We got fractions of fractions. This lets us remember our subtracting, our adding, and our dividing all at the same time. Super gross. Doable. Just gross. So, I'm going to zoom it in so we can see it a little clearer because I know it's really big. This is where we split between numerator and denominator. So our numerator has 5 over x plus 1 minus 2x over x plus 3. And our denominator has x over x plus 1 plus 7 over x plus 3.
Do the x plus 1s and the x plus 3s cancel out?
Unfortunately, since we have adding and subtracting in our numerator and our denominator, I can't just start canceling things. I have to have things being multiplied together before we can start canceling. So we're going to simplify numerator, we're going to simplify denominator, then we will do divide. So I'm going to do my numerator in purple, I'll do my denominator in green, and then we will combine together. So if I take my, I'm going to not put that close to the wall, so I space 5 over x plus 1. And we want to take away 2x over x plus 3. What do I need to do to get this to have a common denominator? So this left side needs to multiply by the x plus 3 over x plus 3, because I can only multiply it by a funny looking 1. And the right hand side needs to multiply by the x plus 1 over x plus 1, the piece it's missing. That's going to get them to have that common denominator. So then we're going to be able to do our subtraction here. So our denominator is going to have our x plus 1 and our x plus 3. And our numerator is going to have our x times 5, which is 5x, our 5 times 3, which is a 15, minus 2x times x, so minus 2x squared, minus 2x times 1, which is a minus 2x. And we can, again, simplify that just a smidge. I know I'm right here at the bottom. I'm just going to extend this down just a smidge. There we go. Ah! There we go. Ooh. I took the subtraction with it. So I did minus 2x times both. If you just multiply by 2x and do it that way, that's totally fine. Okay, just make sure we remember that we're subtracting both of these pieces. So you can do it this way as well. Either way is fine. But we're going to wind up here with our numerator being minus 2x squared plus 3x plus 15. And we've got our denominator that's the same, x plus 1, x plus 3. So we have fully simplified our numerator. Round 2, denominator. Fight. So same kind of vibe, just with our denominator. So I'm going to take my x over x plus 1 and my 7 over x plus 3. And again, we're going to get these to be that common denominator. Oh, that common denominator is looking awfully familiar. Because what do I need to multiply my left fraction by? The x plus 3. Ooh, familiar friends. We know these guys already. What? And what am I multiplying my right fraction by? The x plus 1. Oh my gosh, look at us rocking and rolling. So our denominator is going to be exactly the same, our x plus 1 and our x plus 3. And our numerator, we're going to have our x times x, which is x squared, x times 3, which is a 3x, 7 times x, we get 7x, and 7 times positive 1, couldn't tell if that was a plus or minus, is 7, not 1. My handwriting's beautiful sometimes. So we can simplify this, combine them together to get our like terms on here. But I'm going to do that on the next step because I know we're going to take this, our numerator, and we want to divide it by this, our denominator. All right, because we're dividing by this. But when we are dividing, I'm just going to rewrite it again. What was that? Keep, change, flip. So the first fraction stays the same. So if you don't want to write it again, you don't have to if you want to do that all kind of in one step. Our first fraction stays exactly the same. It keeps minus 2x squared plus 3x plus 15 over the same x plus 1, x plus 3. Then we're going to change our sign from division to multiplication. And then we need to flip our second fraction. We're going to have our x plus 1 over x plus 3 over our, what was our numerator, x squared plus 10x plus 7. What happens?
The x plus 1 and x plus 3.
The x plus 1 and the x plus 3's cancel out. Because when we're multiplying, these are all being multiplied together. So I can cancel this piece and I can cancel that piece. So when we simplify this, we get our minus 2x squared plus 3x plus 15 over x squared plus 10x plus 7. Good idea to stop and check. Are either of these factorable?
No.
No. So we are done. So the fractions of fractions can be very long. There are ways that you can do this with just like 2 or 3 rewrites. If you can spot it earlier and not write it as many times as I do, 100% okay. You do not have to write it this many times. I know a lot of people that can go straight from here to here by doing this multiplication and flipping it at the same time. If you want to do like here to here to here, totally fine. Skip a step or two. You do not have to rewrite it this many times. These are long, these are gross. But luckily that's as bad as they kind of get. Okay? Questions on that? That is everything 1.4. Yes, sir. Number 72. Let me take a look at 72. I don't remember that one. Ah, yes. I know which one you're talking about. So let's look at number 72 real quick. It is a common denominator kind of situation. So this is 1.4, number 72. It's R. Ooh, let me write it down. We've got R. 3x plus 2 to the 1/2 times 2 times 4x minus 5 times 4.
This is to the 1/3.
1/3. Oh, it's just because I can't read my handwriting. Woohoo! 1/3. There we go. It's because I'm looking at the copy and not at the actual textbook. So yes, please let me know if I have anything wrong. We've got our 4x minus 5 squared times 1/3 times 3x minus 2 to the negative 2/3 times 3. Oh, sorry. It's zoomed in over it. Okay. I'm with you. Gross looking. Ew. What is something that sticks out to you guys?
The 2 and 4, I'm just going to ask that I multiply those.
Mm-hmm.
And raise them both. Just
Yeah, we've got some constants in here. I've got some constants over here. And another thing that's super important for us to notice is we've got a negative exponent. So those are kind of the first pieces I want us to see, because you're 100% right. I can absolutely take these guys out. I can do 2 times 4, and we can get, whoa, wrong pen. There we go. We can do 8, and then the rest of the things are just kind of staying there. I'm going to just kind of lock this page out. There we go, so I can zoom in and right. So we have our 3x plus 2 to the 1/3, and our 4x minus 5. And on the right-hand fraction, I've got my constants. I have 3 and 1/3. What happens when you multiply 3 times 1/3? We just get a 1. And then what we have is we have our 4x minus 5 squared. And with this negative exponent, that goes down here. It's a denominator. 3x minus 2 to the minus 2/3. Oh, positive 2/3. Sorry, because we're in the denominator now. 2/3. So if we want to be able to add these together, what do they need to have?
plus 2.
Common denominator.
Better? Did I fix it? Okay, cool. It has it there again. Brain is awesome. So in order to be able to add these together, I need them both to have that same denominator. So that means I need to multiply this left-hand side by the denominator, that thing over that thing, so that we can have a common denominator. So I'm going to multiply, I know I'm right on the edge over here, 3x plus 2 to the 2/3 over 3x plus 2 to the 2/3. I know it's making our denominator very gross, but it's okay. We can do that. Because now what we can do is we can look at this and say, hey, they all have that same denominator, where we have our 3x plus 2 to the 2/3. Doable. That's the thing. In our left-hand numerator, we've got our 8, which is hanging out. I have 3x plus 2 to the 2/3 times 3x plus 2 to the 1/3. Just 3x plus 2. And then we also have our 4x minus 5. And we're going to add that to our 4x minus 5 squared. I'm going to say, multiply them out, simplify them. You can leave the fractional exponent in the denominator. This one's long and gross. Multiply this out and simplify, and you can leave it like this. You don't need to rationalize this one. It's nasty. Okay. So multiply this out and simplify, and then you're done. I'm just going to leave that last little bit for you.
Miss,
Yes, dear. Mhm.
Put it on the top, like combine with the 3x's to the top.
We can't because of these different exponents. That would put us exactly back to where we were here. If I was to, honestly, if I was to rationalize it out, this is where we'd wind up. That's where we're coming from. So this is basically unrationalizing the denominator. So just multiply this out, simplify, and then leave the denominator like this. Yes, dear.
What about the 3?
Oh, and here,
Yeah, what about that?
times the 1/3.
Oh,
Yeah, those two things cancel out. They just touched so many things in this question. There's so many pieces. It's extra as all heck. It's gross. I'm with you. This one's gross.
what would be the easiest way to multiply the numerator out?
Distribute these guys. Distribute these guys. Then I would distribute the 8 in, or you can take the 8 into one of these pieces and then distribute, and then combine like terms. It's not pretty, but it's doable. You could also like there's factoring things you can do and stuff, but like there's other ways to look at it, but I feel like that's kind of the simplest way. How about a palate cleanse of jumping from the hardest one to the easiest one? Because I know these are gross and this is nasty. So I'm going to show you how we're going to start chapter 2 because it'll make you go, because it's familiar. Because chapter 1 has been all about expressions, things like that. None of these guys have had equal signs. So chapter 2, we're going to get into equations. So we're going to start with stuff like this. Things we've seen. We can do these. I'm going to give us a couple of definitions first, but we can do these, okay? So when we start in chapter 2, whenever we start a chapter, it's always going to start very simple, and then as we go, it'll ramp up. But that makes the jump to the next chapter feel super weird. So we're going to be working with equations, finding solutions, roots, zeros, intercepts. Oh my gosh, those words. They're coming back. So these definitions you probably know. We know an equation is two expressions set equal to each other. It's just a mathematical statement. And that our solutions are our roots that make it true. It's usually the answer that we find when we're solving. It also counts as our x-intercepts, solutions, zeros, roots, all those things. And we're going to look at solving. We will probably do one today just kind of as a palate cleanse. And then we'll start on chapter 2 after the quiz tomorrow. For realsies. Okay? So we're going to work through some solving stuff. Seeing what we remember. Because it's been a minute. Okay. So we're going to look at those ones I showed you that were like, oh, familiar. Way less gross. Especially that left one. Oh, I'll put it back. Don't pout at me.
My brain is not working today.
Understood. I was here more than 12 hours yesterday. I get it. My brain is gooey. I am tired.
Me and my parents were the only ones in my 5th and 6th period class.
That happens. I had at least 2 classes where I had only one family in here. So, I'm just saying. My brain is also gooey. I get it. So we're gonna probably look at one of these. If you want to look at the second one, we could do that. But I also want to give us time to, think stuff.
I'm ready.
Okay. So, got 2 up here. Let's look at the left one. trying to solve, this is when we are going to start crossing equal signs. So we can do same operation on both sides of the equal sign. Huzzah, we're more familiar with that. We love that. So let's look at this left one where we have 4x plus 5 equals negative 3 times the quantity 2x minus 4. What can I do to try and solve this? First thing I'm going to do is distribute. Let's get rid of these parentheses. Zoom in, thank you. It's in a mood today. So we've got our 4x plus 5, and that's going to equal our negative 6x plus 12. What next? Add 6x. Not the only option, but definitely a good one. If we take our smallest one to move, then we wind up with fewer negative coefficients. So adding 6x to both sides, again, you do not have to write out every single step. We're going to have our 10x plus 5 equals 12. It's like you can subtract 12, but you're giving yourself more work that way. Subtract the 5. Get your x's on one side, your numbers on the other. So that's going to give us that 10x equals 7. So what does x equal? 7/10, because we divide both sides by 10. Familiar. Yay, we like those. You can do 7/10, or you can put it as a decimal. I genuinely do not care. That's 0.7. Either way is fine. Okay, so we're going to start looking at solving stuff, finding solutions. The one on the right we can do too. We need to multiply it out a bit, but we can do that and start to solve things. So what do we get when we square x plus 3?
X squared plus 6x plus 9.
6x plus 9. And then we also have this plus 5. Woo-hoo. And what do we get when we square x minus 2?
X
Mm-hmm. Minus 4x plus 4. If you need to, 100% write these out. Put this as x minus 2, and distribute it. Or put it as x plus 3 times x plus 3 and put them through a box. Totally valid. What do we do to solve down here at the bottom? What do we do next here? Yeah, we can combine together our 9 and 5. So we've got our x squared plus 6x plus 14 equals x squared minus 4x plus 4. Again, you do not have to take as many steps as this. Because what else can we do? Subtract x squared from both sides to get those together. What happens when I subtract x squared from both sides?
they cancel out.
Yay! They go away. Then what should we do?
No, wait, add 4.
Add the 4x.
By 3.
It's all good. I was going to say, I couldn't tell if you were aiming for the 4x or the 4. I'm like, either way, we could do that, but just be careful. Because that's going to give us another 10x plus 14 equals 4. So then what do we do? Subtract the 14. We get 10x equals negative 10. So what does x equal?
-1.
Negative 1. And again, you do not have to write it in this many steps. If you do 3 or 4 things in one step, that's totally okay. As long as you can tell what's happening and I can tell what's happening, we're good. You do not have to take any specific number of steps. Just make it clear what's happening. Okay, so we're going to be heading into solving equations and working with all those things we've simplified. We're going to solve them. So I'm going to put up this page. Again, you do not have to start on homework 2-1. We are going to have our quiz tomorrow, and then we will keep talking about 2-1, which is solving. It's basic solving. So that's where we are right now. There's our vibe. We currently have 2-1 listed as due Friday. We'll see how that goes, how much we get through tomorrow. 2-1's pretty short.
I'm just glad I don't have to sit through the Century Resource guy again. Because I technically